To solve a rational equation like this one, 1 over x plus 4 over 2x is equal to 1 over 6. The goal is to cancel all the denominators. Now the nice thing is, you can do this by using the least common denominator, the thing that we were talking about in our previous lesson. If you look at the three denominators, we have x, 2x, and 6. The one denominator that works for all three is 6x. So just like walk through why this works. In this first fraction, you can just multiply by 6. In the second fraction, you can multiply by 3, changing that 2 to a 6. And in the last fraction, the only thing that's missing is an x, so you can just simply multiply an x in its place. Once you have decided that 6x is your least common denominator, you can multiply it to both sides of this equation. So let's check that out. I have 6x times the left side is equal to 6x times the right side. The left was 1 over x plus 4 over 2x, and the right side is 1 over 6. If you like, you can write this as 6x over 1. Okay, I'm going to distribute this 6x to both terms on the left side, and on the right side, it only gets multiplied to the term right next to it. So I'll just copy this whole thing down again. We have 6x over 1 times 1 over x, plus 6x over 1 times 4 over 2x, and this is equal to 6x over 1 times 1 over 6. If we scan through the three sets of fractions, I can cancel common factors between the numerator and the denominator. So like this x cancels with that x, but nothing else cancels. Here this x cancels with that x. You could cancel the 2 into the 4, but why not cancel it into the 6, leaving us with 3? And then on the very last fraction, 6 goes into itself once, leaving us with just x. And if you look across from left to right, all of the denominators are now just 1. You don't even have to write them. We can just copy down what's left over in the numerators. We have 6 plus 12 is equal to x. Or 18 is x. This is the solution to our equation. So let's try this idea in a slightly more complicated example. So again, I want to use this idea of a least common denominator to cancel every single fraction. And the very first fraction on the left I see is not factored, so I'm just going to start by factoring it. This is 1 over x times x plus 4 plus 2 over x is equal to 3 over x plus 4. I can now determine the least common denominator, and that would be x times x plus 4. Notice that this denominator I can get by multiplying this by x plus 4 and this by x. I don't need another thing to do that. So my next step is now to take this least common denominator and multiply it to both sides. But let's be a little bit more efficient about it. Instead of making this a two-step process, why don't I just put the least common denominator here, here, and here. So I'll just skip that distributing step. This would give me the following. I have x times x plus 4 over 1, and that's multiplied to the very first fraction. I then would multiply that to the second fraction. And then lastly, I multiply it to the very last fraction on the right. I can now go through and cancel all common factors. The very first one's nice. X plus 4 and x plus 4, as well as x and x completely go away. This entire fraction is just 1. It's 1 times 1 over 1 times 1. So I'm just going to put down 1. Okay, for my second fraction, I can only cancel this x with that x. And I'm left with 2 times x plus 4. And on the right, I can cancel the x plus 4s, and I'm left with just 3x. by doing this process, I've changed a rational equation into a linear one. So let's solve it. If I combine terms on the left side, I get 2x plus 9 is equal to 3x. Subtracting 2x from both sides gives me 9 is equal to x, and this is my final answer.